Cool. So welcome everyone to the 2020 APAC Groundbreakers Virtual Tour by APAC OUC. And this year our event would be the biggest one ever done with 174 sessions. That would be including normal sessions, workshops, and hands-on labs from 123 different speakers over 11 days. Also, it would cover sessions on 4 different languages. So please remember to register to as many sessions as you can. And all sessions would be available to replay as many times as you want for 2 weeks after the initial session date and time. You can also interact with the speaker at any time during that 2 weeks by posting questions or comments directly in the playback session page. Now, I would like to say thanks to all Oracle user groups and Java user groups that made this event possible, and also to our sponsors, Oracle Groundbreakers and CloudDB. And now for today's session, Immediate Relief, Fix the SQL Now by Ahmed Alomari. Please feel free to write questions at any time during the session at the Q&A tab of the Zoom webinar, and the speaker would be answering them at the end of the session. If any issues during the presentation, please feel free to contact me at any time in the chat tab of the Zoom webinar. Now, without any more delays, I would like to leave you with this amazing session by Ahmed. Take it away, Ahmed.
Thank you. All right, good afternoon, everyone. My name is Ahmed Alomari. I'm going to talk about immediate relief and providing SQL fixes when you don't have access to the source code. So the agenda for today is to cover some of the challenges associated with dealing with SQL performance issues in production, and then tips and techniques to help identify the problematic SQL, and then some options to tune the SQL without having to make code changes. So one of the challenges, of course, is after identifying the expensive SQL that may be impacting the system, might be causing general performance issues, for all the users due to the amount of resources it's consuming. It might also be, performing a lot of excessive I/O and then starting to cause I/O latency for transactions, or it might be also causing a concurrency issue. In certain cases, the SQL might be part of a third-party app, in which case you don't have access to the source code. Or maybe it's a custom application, but the developers are not currently available to fix the SQL, or it has to go into the development queue, maybe for the next release, or they may not have access to the source code at all if it's a packaged application, for example. And even if they do, even if the customer does have access to the source code, a lot of times the changing the code has to go through the code development cycle. So typically you'll have to open a defect. A defect will have to be scheduled, and then there's some the developer has to assign it to a release or a sprint. Then the change is made, promoted to dev, and then test, and then UAT, and then finally production. And usually the code cycles to production will take some time. So even though you identified the problematic SQL and identified a fix for it, it might not be able to be fixed in a quick time, just because of the code release cycle. So typically, for example, if the system might be performing well for a long time, and then all of a sudden maybe some change occurs, either due to maybe a code change, or some increased data volume, or maybe increased users, for example, and then the performance all of a sudden goes south for that SQL, starts taking more resources, performing more work. Could possibly cause lock contention, because if the SQLs are taking longer, and for example they already updated some records and therefore hold locks, transaction locks, then that can also cause concurrency and downstream effects, and it can also cause backlog in some of the jobs, for example, that may be running in the background. So the SQL statement itself obviously can be can regress for multiple reasons. So when a SQL is performing fine, for example, all of a sudden something changed to cause that SQL statement to take longer. What is the typical reason for that? So one of the most common reasons, for example, would be like changes in data distribution. For example, more transactions got loaded, or some interfaces ran that loaded a decent amount of records, and therefore changed the data distribution, and therefore the execution plan could have changed. Another possible reason is the execution plan might have changed, even though the underlying data distribution didn't change. For example, statistics was regathered, and some of the, for example, number of distinct values, number of nulls, those types of, even the histogram itself, if there was a histogram on a skewed column, for example, even that could have, different ranges, for example. Adaptive plans is also a feature that can cause execution plan changes. For example, one time the SQL statement was parsed with, if it had a bind variable such as a between, like a date range, and between a start date and an end date. And one time the SQL was run with a day's worth of range. Next time it was run with a week's or a month's worth of range, right? That could also cause the plan to change. Any environment changes, for example, in infrastructure, even the session environment, for example, NLS, that could also result in a different plan. Bind peaking is the example I gave earlier. If you have, for example, range predicates, like between is an example, or if you have a like filter that has a bind, maybe one time someone typed in a fully qualified part number, the next time they just typed in, 8%. So that would have, of course, different selectivity. And then obviously there could also be an optimizer bug that you might be running into, which may have caused the plan to change. Code changes, of course, could also introduce, for example, the developer made a change to the SQL. That SQL was running fine all along, but because they added some joins or added some more conditions, or maybe changed the underlying view that was used in that SQL statement, now the SQL statement is taking a different plan and is more expensive. Any patches that could be applied, for example, database patches or application patches, and then of course parameter or infrastructure changes. So these are some of the common examples of why a well-performing SQL statement might all of a sudden start performing poorly. So the important thing that I always say is when you start tackling a SQL performance issue, the first thing before jumping into the SQL itself is find out what is the underlying business process. Where is the SQL statement used? Is it part of an online transaction? If so, which transaction? Is it part of entering an order, booking an order, creating a requisition, for example, or submitting an expense? Is it part of a report, for example? Is that report critical? Does the business need that report? As a part of critical job, for example, as a part of the shipping workflow, for example, or order processing workflow, or is it maybe a finance job, for example? So it's very important to identify the underlying business process as well before jumping into the SQL. So identifying the top SQL, there are, of course, multiple ways to do that, and I'm going to cover some of them. So AWR, of course, is the automated workload repository, which has been available since 10G. That does require the tuning pack, as part of the enterprise edition. There's also ASH, which is active session history. Again, also requires the tuning pack. And that provides another mechanism to identify top SQL with some drill down information. There's also the AWR SQL report, where you can run a SQL report for a specific SQL statement that will give you kind of drill downs of when the SQL is used, some details about the execution plan as well. And if you don't have any of those features, of course, StatsPack is still there. That has been there since I think 8i days, which is also free. So that can also be another way to capture high load SQL, as well as manual monitoring, for example. So typically in the AWR, there's a SQL statistics section, which will have essentially all the top SQLs by the various areas. So there'll be a SQL order by elapsed time, by CPU, by IO, by physical reads, by parsing, by cluster weights, etc. And what I recommend is that you essentially, review the section that's relevant to the problem that you're trying to solve. So for example, if you're seeing a lot of, parsing activity and it's causing a lot of, maybe latch contention or shared pool contention or mutex weights, then you would probably want to focus on the section SQL order by parse calls to identify which SQLs are causing the most, parses and tackle those SQLs. If you're seeing, for example, an IO performance issue and the database or system is just doing too much IO, the IOPS is very high and it's overloading the storage frame, and the overall latencies are very slow because of that, then you would probably want to tackle the SQL ordered by reads or SQL ordered by physical reads as an example. If your system was running, at high CPU, like 90% CPU or 100% CPU, and you wanted to tackle those top consumers by CPU, then you should look at the relevant section ordered by CPU time. So, you should try to utilize the relevant section based on the problem that you're trying to solve. So for example, in the elapsed time section, you'll typically see in the AWR section, it'll have, of course, the elapsed time, which will be the total. That means across all executions. Then it'll give you the number of times that SQL statement has been executed within your snapshot. So if your snapshot is hourly or every 30 minutes, or depending on your AWR configuration. And then it'll show you how long it takes per execution, and then what percentage of that does it represent in terms of the total database time. So for example, if we look at the first SQL, we can see that it took about 691 seconds across all of those 16,000 executions. So each execution took approximately 0.04 seconds, and that represented 25% of the load. And then the next SQL statement after that, for example, took 422 seconds, but was executed 3.3 million times. And so individually, it's not really expensive, but it was executed 3.3 million times, which suggests that probably that SQL statement is inside of a loop. And then, we'd need to investigate why is it being called so much, for example. And then on the read section, for example, it'll have the physical reads, it'll have executions, how many reads per execution, for example. So the one listed first, it did 213,000 physical reads. And each time it ran, it performed 30,000 IOs roughly. And it was executed, 7 times, for example. And then you can also generate an ASH report, obviously by SQL ID, or you can query the ASH repository directly, depending on your preference. So from Enterprise Manager, you can go to the run ASH report function, and then you can specify the dates, and then you can filter by SQL ID. You can also filter obviously by session and other criteria like module and action. But if you're drilling down on a specific SQL, then you can run it by SQL ID. And then the ASH report by SQL ID will look like this. So it'll basically show you the top SQL with the top events. And a couple things that I've kind of circled to kind of highlight. So the first thing that I typically look at is the column that's sample number of executions. This gives you an idea of, for example, if you're looking at a top SQL, was it executed one time, for example, during that session, or was it executed multiple times? So in this case, we can know that because it's saying that it was executed 19 times based on the sample, then we know that SQL statement was executed multiple times. It wasn't executed just once, for example. So that can be often useful too, because you want to know, is this just a one-time execution and it's taking time, or is it being executed in a loop, and therefore the time is just adding up, for example. So that's something you should always keep an eye on. And then in this case, it's showing that pretty much 99% of the time spent by that SQL is in that row source, the DB file sequential read for that specific table access, and then there were some GC rack traffic associated with that as well. But essentially, 99% of the time is consumed by that SQL statement and that particular row source. You can also run the SQL details active report, which will also give you drill downs as well, and some new drill downs were added in 19C as well. So for example, for this specific SQL statement, which is executing against the workflow table, you can see, for example, how long the statement took. So in this case, the statement took about an hour. The database time itself was about 1.2 hours. And then it gives you a breakdown of how much time was spent in PL SQL versus Java versus the SQL statement. So in this case, the overwhelming time is spent in the actual SQL execution, which is expected. But had some time been spent in SQL or Java processing, that would have also been reflected here. And then you can see on the IO statistics, it'll tell you, for example, how many buffer gets it did, how many IO requests it performed. So in this case, it performed almost 7.6 million IOs and basically went through 140 gigabytes of data so far. And then you can have it'll display the actual execution plan. And then on the right-hand side, under the activity, it'll show you where the bulk of the time is. So for example, on this execution plan, it's using that index N1 and then hitting the table access after probing the index. And then you can see that 81% of the time was spent in the table access. The actual index lookup was not expensive. And then for SQL statements that are executed in PL SQL, one added benefit too is that when you look at the SQL details section, if you're using Enterprise Manager, it'll actually tell you the package name and the line number where the SQL comes from. So in this case, this is a workflow SQL, and you can see that highlighted at the bottom, it shows that it's coming from the WF_Q package, and the line number is in parentheses, which is 940. So for server-side PL SQL, meaning that SQL statements inside, packages, procedures, functions, triggers, the $SQL has a column called program ID, and that program ID maps to the object ID in DBA objects. And then the program line number is the line number within that PL SQL unit. So, if you can either see it from Enterprise Manager, where it'll tell you the package number, and then if you were to click on here, it would take you to that package, and you can go to that line number to see that SQL. Or you can directly query it from $SQL. If you had, for example, a SQL ID and just wanted to look it up to see which program unit it's coming from. Okay, so options to tune the SQL. So the first thing is from the statistics is we need to make sure that the statistics are valid and representative. Notice that I didn't say that the statistics have to be current because it's not important that the statistics are current, meaning, for example, you have to gather stats every day or every week. It's only important that the statistics are representative of the data that currently exists. So for example, if you have, a billion row table and say journal lines, and it went from 1.1 billion to 1.2 billion, that's not really a reason to gather stats because, the data distribution is, largely the same, and the distribution between like the headers and journal lines will largely be the same. And that's one of the reasons why a lot of the larger, databases these days, the multi-terabytes databases, they typically don't gather stats that often. It might be monthly or quarterly, only because obviously it takes a long time and it usually does not result in any plan changes as such. So you just need to make sure that the statistics themselves are representative. The other thing you should do is review the execution plan of the SQL statement that you're trying to tune, and then look at the cardinality and the row source to make sure that the cardinality is representative. It won't obviously be exact, but it should be relatively close, just to make sure that the cardinality and selectivity estimates are reasonable and it's generating a good plan. I also recommend that if you want to dump the execution plan, make sure that you use the DBMSX plan DisplayCursor procedure to do that, because that'll dump the SQL text and the filter dump as well. So you'll get a little more details rather than trying to generate an explain plan manually from SQL Developer or Toad, for example. In addition, the DisplayCursor will actually show you the runtime plan that was actually used versus a manual explain plan, which may or may not be an actual plan used at runtime. So an example of this DisplayCursor, essentially you provide the SQL ID and it'll display the output like this. It'll show you the SQL statement and then the child number. It'll show you the plan hash, and then it'll show you the individual row sources. So here you can see that this was an update statement against QP qualifiers, and it's using the N8 index, and the optimizer decided to use skip scan on the N8 index, thinking that the cost is very low. But this would be an example of something you'd want to look at and say, okay, the optimizer here is estimating that one row is going to get updated. And so you'd want to look at it to see if this was actually the case. Now one example here is that if you see the main filter condition is list header ID. And so when you update the qualifiers, you're specifying the price list ID. And in this case, it looks like the optimizer estimated that the list header ID that's being provided is a single list header ID, meaning that the between, in this case, the bind B2 and B1 are the same value. Had it been like a larger value, maybe 100 price lists or 1,000 price lists, then that should have been reflected in the cardinality. So this is something that you would want to correlate to make sure that, in fact, the values that are actually being passed are the same values for the low value and high value. Then you should also verify these statistics by querying the dictionary, either like for example DBA tables, DBA indexes, and DBA tab columns, for example, which has the column statistics. And so here it's showing the statistics, the number of rows, and then the individual column stats, and then the number of distinct values, for example. And then the individual index stats are also shown here as well. So we can see, for example, that any index, the number of distinct values is 100, which seems very low. And that's why the optimizer assumed that a single row is going to be returned. So the statistics are exposed by the view DBA tab columns. So that has all the column stats. And a couple of the column stats that are relevant are the number of distinct for the columns, and then distinct keys at the index. And the optimizer will use both depending on, for example, the predicates and the filter conditions you have. So NDV is the number of distinct values. That's one of the key calculations that the optimizer uses to determine how selective your query is. So for every filter condition, it tries to estimate how many distinct values is going to be returned. And based on that NDV calculation, that's then fed into the cardinality estimates in order to calculate, for example, how many rows per row source, and then also calculate the join cardinality, for example. So if the NDV is off for columns, a particular column or set of columns, then you might want to check if the data is skewed. And if it is, maybe try gathering stats using a larger sample size. I recommend using auto sample size so that the optimizer, when you gather stats, you only have to, of course, gather stats once. And by using auto sample size, the DBMS stats will automatically determine if there's skew in the column. And if there's skew, it'll graduate the sample size. So for the columns that are skewed, it'll graduate the sample size to a larger value to make sure that you have an accurate value for number of distinct values, because that can definitely lead to suboptimal plans. And sometimes that can explain scenarios where, for example, somebody gathers stats on a table and performance is fine, and then somebody gathers stats again on the same table, then the performance of that SQL statement went south. That's usually due to sampling, and the NDV is probably off. So again, on the statistics, just make sure you review the execution plan, check the cardinality. So for example, here, the query is querying the workflow item activity statuses and then joining to WF process activities. And it's looking for deferred activities or waiting or pending activities. And so here the optimizer is estimating there's about 63 such records. And then when it joins to WF process activities, of course, that's a unique join. And then the final estimate is 63 rows. So that's something you'd want to, cross-verify to make sure that the query is, averaging around those number of rows per execution. If there's not, then there's probably an issue with the histogram on the activity status column in that it's not representative of the cardinality estimates. So the other thing you can do is, for example, what happens if, let's say, your cardinality estimates are just way off? Like going back to this example, the optimizer here is estimating 63 records. Let's say, for example, the actual query produced 1,000 records, right? In that case, it would definitely the estimates are off. So one way you can kind of compare actuals with estimates is to use that gather plan statistics hint in order to generate the cardinality estimates to compare with actuals. So pretty much all you have to do is add the hint gather plan statistics and then run the SQL statement. And what you would do is essentially you run the query with that hint. That will generate additional row source statistics so that you'll be able to compare actuals with estimates. After your query completes, you then basically run the DisplayCursor, given the SQL ID for that statement and the child number, and then you specify in the format all stats last. And then after you run the query with the gather plan statistics, by running DisplayCursor, it'll show this output. So notice that this is kind of the normal execution plan format, but it has some additional columns that you typically don't see. So one of them is the estimated rows, which is the E rows. And then there's the A rows, which is the actuals. And then there's A time, which is how long the statement took, the actual time. And then it gives you the buffer gets and the disk reads. And those are actuals. So basically you get additional statistics to try to compare to see why the optimizer's estimates are way off and which step. So here, if we look at it, for example, we can tell that the SQL statement, the optimizer estimated that the SQL statement will produce a single row, when in actuality, the query produced 16,000 rows. So obviously it was way off. And then what you can do is you can kind of, look at the individual row sources to find out which step did it really have that material difference in. So as an example here, if we look at the WSH delivery details, the optimizer estimated that 520 rows would be returned by the index probe. And then after applying table filters, that would be reduced to a single row. And see, the actual rows returned is 227,000. So it was way off. And so we know that the issue is on WSH delivery details. And then it's a matter of, nailing down the filters on there, or, refreshing the stats on that table, maybe with a higher sample size, or possibly having to gather some histograms to register that skew. But this is an example of, and then we can see from the first table, the WSH picking rules, we know that's a single row anyway, because it's already doing a unique scan. But you can see the estimated rows and the actual rows is the same. It's only when the next join, which is to WSH delivery details, that's the one that caused it to be way off. And then since that produced a single row, the optimizer assumed the rest produced a single row as well. So this is another nice way to basically be able to drill down on a SQL to find out where the estimates are going wrong. And it's also useful too to be able to find out which step of the SQL statement is taking the bulk of the time. So here, for example, we can see the statement took 2 minutes and 18 seconds. And if we want to look at it, we can see that the WSH delivery details portion of itself took 52 seconds by itself. So we know that pretty much that's the bulk of it. So almost 1 minute was from WSH delivery details, and then there's another 47 seconds on the OE order lines also. Between those two, you're almost at 2 minutes. So those two steps account for the bulk of it. And again, this is a nice feature too, because you don't have to generate a SQL trace. Normally to get this information, you'd have to generate a SQL trace. Whereas, with this, you can just add the hint, run the SQL, and then, dump the runtime plan. Okay, so options to tune the SQL. So SQL Profile. The SQL Profile is part of the Oracle Tuning Pack. I've given the link here for 12C as well as the 19C. But basically, what is the purpose of SQL Profile? The purpose of SQL Profile is to essentially try to find an alternate execution plan that may deliver better performance. So a lot of times, for example, when you have a complex SQL statement and you're trying to tune it and find alternate plans, a lot of times the optimizer generated an inefficient plan or suboptimal plan because, for example, the cardinality estimates are off, the number of distinct values is off, the join skew is off, for example, or the SQL might have complex expressions such as MVL or decode, for example. And so the statistics themselves just led to bad estimates, therefore led to a bad plan. And what SQL Profile can do is basically use data sampling, to find an alternate and more efficient plan. So it can essentially say, okay, this is my default plan. Every time I hit, for example, this table, I'm estimating that's going to reduce 10 rows. But every time I actually sample and apply the filters, I'm getting thousands of rows. So it can use that corrective information called corrective statistics to input that into the execution plan, and therefore hopefully generate a more efficient plan because it has better information, better selectivity, better cardinalities. And so that's the idea of using sampling essentially to run the query, apply the individual filters, sample the individual tables that are referenced in the SQL to try to be able to create a better plan. And SQL profiles, there's a number of ways to manage them. You can do it through Enterprise Manager using, for example, like the SQL Tuning Advisor, or there's a PL SQL interface, DBMS SQL Tune as well. So as an example, the way it works is a SQL statement, and when it's executed, and there's a SQL profile for that, then that'll be looked up and fetched from the dictionary. That SQL profile will be applied, and then it goes through the optimizer. The optimizer generates a plan, and then that plan will be either executed or it can form the basis of a SQL plan baseline, which we'll also talk about. So SQL profile, for example, let's say I'm looking at this particular SQL statement, which has identified as a top SQL, and I want to try to tune it. So, and from the SQL details page, I can click on the SQL Tuning Advisor as actions, and then I can schedule the SQL Tuning Advisor. That brings up the Tuning Advisor page for that specific SQL statement. So you can see it creates a SQL tuning task with a new task ID. and you can specify how much time you want, whether you want to spend the full 30 minutes or whether you want to limit it and say, just try for 5 minutes and see what you can come up with. That's configurable. And then whether you want to schedule this to do immediately or whether you want to schedule it later at some point of time. So when the SQL tuning task runs, it'll basically again do data sampling, for example, and analyze each individual table and filter that's included in the SQL, and then it'll come up with recommendations. So some of the recommendations here, for example, it's saying that the index statistics, for example, are stale, so that should be refreshed as a recommendation. It also found that there's a better execution plan that it came up with, and it tells you how much it will improve. So here it's saying that execution plan would improve performance by 86%. And then you can basically compare, the old plan and the new plan, before accepting it, for example. It also recommended, for example, creating an index, and it's saying with this new index, that'll improve performance 56%. So the best recommendation that came here is with the SQL profile, which came with an alternate plan, and it's saying that that's going to improve by 86%. So the other benefit too is it allows you to actually, it'll run the SQL by comparing the plans. So it'll actually compare the SQL statement with and without the new plan. So if you, for example, if you look at the original plan, it took about 1,400 seconds, for example, and then with the new plan using the SQL profile, it came down to 546 seconds. So almost 1/3 improvement. And then also it shows you how much CPU time that it reduced as well. So it's not only just showing you the plans, but it can actually run them and then give you the execution statistics to show you that it actually improved. And then you can also compare the plans. So it'll show you the plans side by side, so you can see the top plan versus the new plan. So the original plan is the one at the top, and then the new plan it changed the join order to be a little more efficient, and then the overall cost was a lot less. And then you can basically decide whether you want to implement that, or i.e. accept the SQL profile. If you implement it, then it'll create that SQL profile, and then that next time that SQL statement is executed, it'll be used. So, when would you create a SQL profile? So, after you do the SQL tuning analysis, it'll list you the different options. Then you can accept or publish that profile. And then basically the SQL profile column, if you're looking at VSQL, for example, that'll show the the name of that SQL profile that was created. It'll show whether it's being used. And if you display the plan in Enterprise Manager as well, it'll also show the SQL profile in the notes field. So as an example here, if you again run the DBMS Xplan DisplayCursor after creating the SQL profile, then it'll show you the SQL ID. It'll show you the row source like it normally does. At the bottom of that, it shows what's called the notes section. And there you can see that the SQL profile, it'll give you the SQL profile name, and it's telling you that it was applied to the SQL statement. So a couple of things to keep in mind with the SQL profile is it may not necessarily result in a better plan or improved performance. So something you definitely need to test, because again, it's doing sampling and it's doing testing. But definitely you want to test the various scenarios to make sure that the profile is actually better in all the cases. Especially, for example, if your SQL statement is using like staging tables, interface tables, temporary tables, right? At the time of sampling, that data will not be there, and therefore the profile recommendation may not necessarily be valid. So just keep that in mind. And the SQL profile doesn't necessarily hardwire the plan, right? Even sometimes you may have experienced when you create a SQL profile, trying to get a desired plan, over time that plan could change, even though it still shows it's using the profile. And that's because it doesn't necessarily mean that you're going to get a fixed plan, right? The idea of the SQL profile is to provide more information so that it can lead to a better plan. But again, it's something you need to review and make sure you test all the scenarios. SQL Patch. So SQL Patch is another feature that can also be used to override SQL statements, for example, with hard-coded hints or hints that are not optimal. For example, a good example is, for example, somebody, a developer put a hint in a SQL statement, such as like an index hint with a wrong index name, or maybe put a parallel hint in the SQL statement, or force it to do a full table scan or something like that. And you want to basically ignore that hint or remove that hint, for example. So here's an example where a developer put in a parallel hint against the item table where the filters organization ID, and that's going to force a parallel full table scan, for example, and that's not something probably we want to do because a lot of the smaller organizations they may not have that much data, and so doing a parallel full table scan for every organization is going to be very expensive. So in this case, what you can do is you can create a SQL patch, and basically the syntax for that is you query the SQL text, and you basically specify the hints. So in this case, I'm specifying the no parallel hint, and I'm using the fully qualified query block notation hint to specify the query block and then the table alias, and then I give the hint that I want, which is a no parallel, and then I basically call that API DBMS SQL Tune internal create SQL profile, which then creates the patch, and I'm saying it's of type patch essentially. And the name of the patch is at xxspcrm_patch2. And so then when you run the SQL statement, then the SQL patch is being applied. You can see here the previous plan was actually doing a full scan with parallelism because of that parallel hint. Now the parallel hint was replaced with no parallel, and now it's using the index on the org ID. And it's also telling you that the SQL patch has been applied as well. So SQL patch can be another feature to also bring immediate relief to a SQL statement where you want to replace the hints or augment the hints, for example. So SQL profiles and SQL patches with hints, again, there's another scenario where you want to kind of use like an outline, for example. A specific execution plan, and you kind of want to hardwire that plan. So in that case, what you would do is you would get the full set of hints. And so what you would do is you would dump the plan when you're using the DisplayCursor, and you would use the format outline. And when you use the format outline, it basically generates the normal output, with the SQL text, the execution plan. At the bottom of that, it gives you the outline data, which has essentially all the hints needed to reproduce this plan. So the idea is that you would basically dump the plan that you want. This can be used in a scenario where, for example, a SQL statement might have multiple plans, and one of the plans is the most efficient, and you want to use that specific plan hash all the time. So then you would basically dump the SQL with the outline. That would give you these hints. Then you can create a SQL profile to specify those set of hints. As an example, this is the syntax. So you would basically instantiate the SQL profile structure. And then in this case, I have 13 hints, so I need to extend that structure 13. And then you specify all the hints that you want. And then you create the profile using DBMS SQL Tune, import SQL profile, giving the SQL text and the hints that was just created. And then when the SQL statement is run, it'll show that the SQL profile was applied, again, in the notes field. So that's how you create a SQL profile with a full set of hints in the scenario where there's one particular plan that's the most efficient. Now, SQL patch can also be used in another scenario where sometimes, for example, developers put in hints that are not optimal for all cases, and you essentially want to ignore those hints. Another good example is sometimes the hint was put in like legacy code, and now you upgraded the database to 12C or 19C, and that optimizer bug was fixed a long time ago, and you just want that hint out so you can get a more efficient plan. Let the optimizer choose a default plan. Or another example is the default plan is more efficient than the hinted plan. So in that case, what you can do is you can create a SQL patch, and you can use the hint that ignore optimizer embedded hints. What this will do is the optimizer will ignore whatever hints are in the SQL itself, and then, which means that it'll generate the default plan as if the hints were not present. So this is a way of, again, of being able to create a SQL patch without having to change the code, because the code still has the hint in there. You just want to create a patch to ignore those hints, for example. Another feature that's also available is what we call cancel SQL. And this is I believe this was added in 18C. So it's there in 18C and 19C. And so what you can do is you can actually cancel a SQL in a specific session. So typically today, for example, if you have a long-running SQL, most times what DBAs do is they just kill the session. But when you kill the session, sometimes that can be disruptive because the session is aborted abnormally. It loses its transaction state. Whatever work it was doing before, is lost. It has to, roll back, and there might be some manual cleanup that's required. What this does is basically for a session that's currently executing, you can just cancel that specific SQL, and the session will just abort the current SQL call. The session itself is still valid, just that specific SQL would fail with an ORA 1013. But the rest of the session can resume. It can start executing additional calls. You don't cause the actual session to be aborted. And the syntax for that is you do alter system cancel SQL. The first number, that 546, is your session ID. The second number is the session serial number, and then the third argument is the SQL ID. So, for example, if your SID was 546 and was running that expensive SQL 7XB, by running this alter system cancel SQL, that SID would then finish that SQL call, and they would get an ORA 1013 error. So that's a nice way of canceling the SQL without aborting the SQL altogether. There's also a SQL quarantine feature, which is new in 19C. So this is nice too, where, for example, you want to quarantine a specific SQL statement. For example, let's say a SQL statement has 2 execution plans, and one of them is a really bad execution plan that you just don't want to use. You only want to use one particular plan that's more efficient. And so this is a way of basically using that quarantine package to quarantine the SQL by using that DBMS SQL queue package. And you could do it, of course, by SQL ID, and you can quarantine by SQL text. And then there's a view DBA SQL quarantine to monitor. And $SQL also marks whether the SQL was quarantined and how many executions was avoided. So the way to do that, for example, is you specify the quarantine configuration. In this case, I'm doing it by quarantine by SQL ID. So I'm saying this specific SQL ID, that's 7CQ, and this specific plan hash, I want that quarantined, meaning whenever the SQL statement runs, don't ever use that plan hash 34650. So that can be useful, again, in those scenarios where a SQL statement has multiple plans and one of them or two of them are just really bad performers. This is a way of quarantining them so that that plan hash is not used. And of course, you can also do it by CPU time or elapsed time. So you can say, for example, if the SQL statement reaches 10 minutes of CPU, then quarantine after that. If it exceeds 30 minutes elapsed time, then quarantine as well. So it doesn't have to just be by plan hash. You can also do it by CPU time or elapsed time, for long running SQLs, for example. There's also the SQL Repair Advisor, which, for example, so this isn't for performance issues, but this is more for scenarios where the SQL statement might be failing. It might be throwing like an ORA 600 error or a 7445 core dump or some other internal error. So it'll run the diag package, which will give you some diagnostics about the SQL, to see if there's any possible workarounds or known issues. And then the SQL plan management. Basically, the way that works, again, as part of the advisor, so that there's actually a SQL tuning task that's running in the background by default. And essentially what that does is it looks at all the top SQL from AWR as well as the live cursor cache, and then tries to come up with recommendations either through profiles or SQL plan baselines as well. And so that task can also be configured. So you can determine whether it's running or off or automatic by running this query or by checking the DBMS SPM configure package. So real quick, SQL profiles and SQL patches, again, they're really useful in scenarios where you would like to improve the performance of a SQL and you don't have the luxury of being able to change the application code or underlying SQL text, or you just want immediate relief. For example, it's really causing an impact for end users and you want to be able to improve the performance quickly in production. It's also another option. I always recommend that if you do create SQL profiles and patch, make sure you catalog them, keep track of them, because, for example, if you upgrade the database, I typically recommend that you revisit those. A lot of times you may not necessarily need those after the upgrade, so those can be disabled, for example, but just always catalog them so that you can review them to see if they're actually needed, because there might be a much more efficient plan available than what the profile is using. So thank you. I'll take any questions. Anybody has any? That's my email as well. Feel free to reach out to me. So there's one question here. How do I enable the row source statistics for standard EBS programs if I need to get the E rows and A rows? So a couple ways you can do that. You can insert an alter session. So in eBusiness Suite, there's a initialization SQL custom profile that can be used to insert like an alter session. So you can do alter session, set statistics level to all. And in that case, it'll populate the row source statistics for every SQL statement that session runs or job runs, for example. That's one way. Another way is to insert the gather plan statistics hint in the couple of SQL statements that you're trying to profile. Or other option is for the SQL statements that are showing up as top, extract those SQL statements and then run them manually, with the gather plan statistics. So a couple options there. Any other questions?
Cool. I guess there's no more
Thank
question. So, yep. Thank you. Thank you, Ahmed, for for sharing your knowledge with the community, and to the rest of the attendees. Thank you for attending this session. And of course, you can always view this recording in the Groundbreakers website, and you can always check with Ahmed if you have any other questions. And yes, don't forget to register to all the other sessions that in the next few hours, I guess, few more hours. And yeah, enjoy the rest of the conference and have a good day.
Thank you.